Alright, so we're going to be looking at 5.4. We're going to be finding the greatest common factor and least common multiple. The way that I most commonly use is the first method that's explained, but there are some other methods that I was not taught that I do intend to model just in case you like those better. And then you can use either method that you would like to. However, I just generally stick with the first method. It's the first one that I've learned, and it's I guess more simple for me to do it that way because I have it committed to memory already. But if you're learning this, you can choose either method that you want. Okay, so finding the greatest common factor, here's the explanation. You break it down to primes. Right here, it tells you break it down to primes. And then after you do that, it says the greatest common factor is the product of primes common to the factorization, so the ones that they have in common, and then you're going to use the prime raised to the power indicated by the least exponent, so the one that's the smallest, which I'll show you what that means. Sometimes the wording can be confused, but here it is just in step. Write the prime factorization, choose all primes common to all factors, so the ones that they have in common only, and you're going to raise it to the power of the smallest, which they mean the least exponent, and then from this product that will give you your greatest common factor. So this is a method I use, which they have some examples here. Alright, so you can look through those, and I will do one like this for you. We have finding greatest common factor by prime factors method. So this is one that I was not taught, but they show you, put them in a row, divide the numbers by common factor, try 2, 3, so on, and then divide the quotients by the common prime factor. So you'll keep doing this process until no prime will divide into all of the quotients. So here's what they're doing. They start out with 12, 18, and 60. And then the last step is you break the product of those. But you start out with 12, 18, and 60. Divide them all by 2. All right, and then the result right here, all of these numbers are divisible by 3. So in the next step, they divide them all by 3 and write the result here. Now there's no number that you can divide 2, 3, and 10 by, that all three of them are divisible by. So they stop there, and you multiply these two terms that you divided by. 2 times 3 is 6, so 6 is the greatest common factor. This is a neat method. I think it's worth using. I may actually switch. They also have a Euclidean algorithm. Okay, so what this does, I think you can only use this with 2 numbers, but not more than 2. That's what it says, but not more than 2. So if you have 2 numbers, you start out by dividing. Okay, the larger number is going to get divided by the smaller number, and you only focus on the remainder. Then you bring the remainder down, and then you divide by the smaller of the numbers again, and you will keep doing this process until you end with 0. That last divisor, the last number that you divided by, or what they say the last positive greatest common factor, the last positive remainder is your greatest common factor, so that would be 6. Some books, I think I've seen it called the last divisor, the number that you divided by. So your greatest common factor is 6. This only works with 2 terms. Okay, so that might be a little bit more work. As you can see, I would definitely recommend using this method more than that other. Okay. Now, this is just a description of that common factor. Divide by the larger, keep going until you get a remainder of 0, the last positive remainder. Okay. Did I go too soon? At the very bottom. Okay. Here's where they start talking about least common multiple, because we're going to also do this. So they give you some numbers, 30, 13, and 10, and we're going to find the least common multiple. So we used to list all those numbers and just multiply them out until we found the smallest one that they have in common. That could take some time if you have some really big numbers. So here is the definition. Write it in prime factorization. And this is the first method I learned, because you use the prime factor when you find the greatest common factor and when you find least common multiple. But you write the prime factorization. You're going to choose all the primes, so every number that shows up, and you're going to raise it to the power with the greatest exponent. So you compare them all and use the greatest exponent of ones that repeat. So from this product, that will give you the least common multiple. So I will model this for you. But here's an example. They do 135, break it down into primes, 280 and 300. Okay, so they will take 3, 5 will be a part of there, 2, 7. So all of those numbers, 2, 3, 5, 7, they have them listed 2, 3, 5, and 7. They take the biggest exponent. So out of the 3s, there's only, well, they have this 3 and this 3. So you have 3 of them here, so you're going to choose that one. Out of the 5s, they have this one, and they have this one that's squared. They choose the biggest one. You have actually a 5 here and a 5 here. But out of them, you choose the biggest number, the biggest exponent. The 2, there's a 2 to the second, a 2 to the third. You choose the biggest one, 2 to the third. And then there's only 1 7. So that's why they have those highlighted. You're going to choose all the numbers that appear. They put them in order 2, 3, 5, 7, and then you just take the highest exponent. And then you also have that second method that we saw, finding the least common multiple by dividing primes. So they put the numbers in a row. They divide by common prime numbers, just like you did with the greatest common factor. Then you divide the quotients. And then it says when no prime will divide all of them, but it will divide some of them. You will continue and then bring down the non-divisible quotients, or the I'm losing my spot. Bring down the non-divisible quotients, yes. And then continue until no prime will divide any 2 quotients. All right. And then the product of the divisors from step 2 and 3 and so on will be your least common multiple. So what does that look like? Here they're showing you this. They did 12, 18, and 60, divided them all by 2, and this is what they had left. These numbers could all be divided by 3, so they did that. Now here there's no number that will divide all 3 of them, but 2 will divide 2 of them. So if you have it, 2 at least, then you can keep going. So they divided the ones that can be divided by 2, and they brought the remainders down. Now there's nothing that will divide all of them. So then they use these numbers 2, 3, and 2, which is a nice way of also getting your least common multiple. I like that one as well. They also have a formula. This only works when you have 2 numbers. You first have to find the greatest common factor though. And once you find the greatest common factor, you just multiply those 2 numbers. So 90 and 80, 90 and 168 they're using. You multiply those 2 numbers together on the top, and then you divide by the greatest common factor. And that will give you the least common multiple. Okay, so those are the methods that they show. I think, just in my opinion, that the second method will be the easiest for you. I will show you both of those, maybe a couple times, and then I'll just stick with the first one. Okay. So other than that, there's just some other problem solving and some examples in there for you to look at. So we're going to jump over to my math lab and start some problems.